All right, this one's going to be a treat here. We're going to be factoring, but I'm going to show you a shortcut that will help you factor expressions a little bit quicker rather than using the model. So we're actually going to start with this one, though, because we already have the answer. So I'm going to show you the shortcut method here, pardon me, and then we're going to try some more here. So we get 12 and 18. So again, we're doing equal groups. We're doing equal groups. We want to see how many will go in each group and what's the greatest number of groups we can make. So we're going to start with the GCF. That's the thing we're going to start with. When we factor, we start with the greatest common factor. That will help us factor. 12, we break that down and off. 4 times 3. 4 would be 2 times 2. Circle, and this is going to be key. You want to circle what you can't break down. The 3, the 2, and the 2 for the 12. 18 would be 6 times 3. Circle 3. 6 is going to be 3 times 2. Circle 3, circle 2. All right. So to find the GCF, we see what they have in common. They have a 2 in common. 2. They also have a 3 in common. 3. Well, what's 2 times 3? 2 times 3 is 6. Now that's the GCF. That's the first step. So to find the GCF, that's going to tell us how many groups. And now we're thinking, well, if we have 12 and we put 12 in 6 groups, how many in each group? 12 divided by 6 would be 2, and that's what's left over with the 12. Look at 12. What's left over is 2. Plus, well, we have 6 groups, you have 18. 18 divided by 6, 18 put into 6 groups would be 3, which is what's left over. So again, you get the same answer, 6 groups of 2 plus 3, but we're going to use our factor trees to help us factor these expressions or put them into groups. All right, let's go for it. Let's try another here. So this time we don't have the entire answer there for us to begin with. Let's factor 63 and 91. Well, I think this is supposed to be 81, so I'm just going to cross that 91 off and put 81. You can't really do that, but I can, I guess, because I'm your teacher, I suppose. All right, so we're going to break these numbers down, 63 and 81. Let's break them down. 63 would become 7 times 9. Can't break the 7 down. We can break the 9 down into 3 times 3. You know what? I'm using this X. I'm going to use the dot because we're going to see on the next side, using that X might be a big mistake. All right, so I'm going to use the dot instead to show multiplication. There it is. 7, 3, and 3. Perfect. 81, we can break that down into 9 times 9. We can break each 9 down into 3 times 3. Again, it's really important we circle the numbers we can't break down. It's going to help us at the end here. All right, what do they have in common? 3. I guess I can write it up here. And then another 3. I'll write it up here. GCF is 3 times 3, which is 9. 9. We can make 9 equal groups. Now we got to figure out what's going to go in each group. Well, if we have 63 and we put 63 in 9 groups, there's going to be 7 in each group. Because 9 times 7 is 63. Plus, if we have 9 groups and we put 81 into 9 groups, 3 times 3 is 9. There's going to be 9 in each group. Now to check this, to kind of see if this works or not, you can kind of do this little shortcut. Well, what's 9 times 7? 63. What's 9 times 9? 81. So this is kind of the same thing as 63 plus 81. It's just being put into groups. The greatest number of equal groups we can make. That's the factored expression. It's just putting this expression into equal groups. You know, I'm feeling pretty good so far. I hope you are as well. So let's try. If you want to try this next one on your own, feel free. So you could probably actually do it a little quicker than me if you want to kind of go for it. But we'll see what happens here. 25 and 60. So we're going to find the GCF first if we want to factor this. If we want to put this into groups. 25 will break down into 5 times 5. Using that dot. We can't break down those 5s anymore, so I'm going to circle them. 60. 10 times 6. Let's do 10 times 6. We can break both of those numbers down. So I'm not circling anything yet. 10 would be 5 times 2. Circle, circle. Again, it's going to be really key that you circle these numbers you can't break down. If you do not circle them, you're going to have a hard time kind of seeing what's left over, which is key here. All right, well, what do they have in common? They have a 5, and that's it. They have a 5 in common. So the GCF is just 5. It's just 5. So that means we can make 5 groups. All right, we can make 5 groups. We're going to put 25 into 5 groups. Well, 25 into 5 groups would be 5 per group. That's what's left over. Now 60 is a different story. If you put 60 into 5 groups, that'd be like 60 divided by 5. Let's check it. If we multiply these leftovers together, we should get the answer. 2 times 3 is 6. 6 times 2 is 12. Plus 12. Key thing here, you want to have the addition sign here. This is adding. We're going to add these. Let's check it. Let's do that quick check I told you about before. 5 times 5, that's 25. 5 times 12, that's 60. That checks out. And again, we have the plus sign here, not the multiplication sign. Plus sign. We're going to be adding these within each group. So we have 5 groups. Each group in it has 5 and 12. All right. Oh, this one's good. There's something happens with this one that's really special. Really special. All right. So 9 and 27. We're going to factor this thing. We're going to break these numbers down. Let's do it. 9 is going to break down into a 3.3. We can circle both. Can't break those 3's down. 27, same thing. Well, not same thing, but we're going to break it down. 9 times 3, circle the 3. 9 becomes 3 times 3. Okie dokie. Got a lot of 3's here, a lot of 3's. Now, what do they have in common? They have a 3 in common. So the GCF would be 3. And then, they have another 3. They have another 3. Is that it? That's it. They have 2 3's in common. And 3 times 3 is 9. Look at that. Another 9. Another 9. All right. That means we have 9 groups. Now, this is where there can be some confusion sometimes. If we have 9 groups, you see there's nothing left over. So some people think, there's nothing left. However, remember, we're putting these into groups. If we have 9 and we put 9 into 9 groups, how many per group? 9 divided by 9 would be 1. 1 per group. Plus 27 divided by 9 into 9 groups would be 3. 3 in each group. Let's double check that to make sure we get 9 plus 27 back. Let's do a little check here. 9 times 1, that's 9, of course. And then 9 times 3 is 27. So that checks out. Yeah, if that was a 0, 9 times 0 is just 0. And 9 is not the same thing as 0. So we're making 9 groups. 1 per group from 9, 3 per group from 27. And again, when it says I read this as, you could do this for the other ones, but 9 groups of 1 plus 3, if you wanted to write those. Okay, so now the ones we're going to do on the next page are a little different. They're a little different, a little tricky. There's something about these that's unusual. You may notice it right off the bat. We have a variable. We have a variable. All right. We're going to follow the same steps, though. We're going to write each term out, 4x and 6. Again, I included the variable here. You want to write the variable down as well. Then we're going to break them down. I can't break x down, so I'm just going to circle x. I can't break that down. I don't know what it is. So I'm going to circle it because I can't break it down. 4, I can break down into 2 times 2. Can't break those down. So we got 2 and a 2 and an x circled for 4. 6 would be 3 times 2. And again, that x is really key. It's really key to have that. Really important. All right, let's see what we have here. We have, what do they have in common? They have a 2. And I think that's it. GCF is just 2. That means we have 2 groups. 2 groups. All right, well, what's going to go in each group? If we have 4 x's and we put those 4 x's into 2 groups, there'd be 2 x's in each group. And look at that. That's what's left over. 2x is left over. Plus, of course, we got the plus sign here. With 6 put into 2 groups, 3 is going to be in each group. So we have 2 groups of 2x plus 3. That's the same thing as 4x plus 6. I'm just going to write one of these down. We won't do all of these, but 2 groups. When we see parentheses like that, we see groups, 2 groups of 2x plus 3. All right, now, again, the key thing here, you got to circle that variable. You got to remember to put the variable in. Let's check it using that little check that we talked about before. 2 times 2x would be 4x, because 2 times 2 is 4 with the x, 4x. 2 times 3 is 6, so that checks out. That checks out. Feeling good about that one. All right, let's try this next one. We got 30, and we got 12x. Whoop, got to move it down. 30, break that down into, I don't know, 10 times 3. Circle that 3. Break the 10 down into 5 times 2. Circle the 5, circle the 2. With 12x, again, you got to be really, really careful, really mindful that you circle the x. The x is part of that term. 12, you break that down to be 4 times. You can do, well, I'm going to do 6 times 2. I'm going to do 6 times 2. Circle the 2. 6, break down into 3 times 2. And we're going to circle the 3, and we're going to circle the 2. Okie dokie. Now, what do they have in common? They have a 2 in common. And it looks like they also have a 3 in common. 2 times 3, I think that's it, right? They have 5 and a 2, nope, and the x. Okay, that's going to be 6. So we have 6 groups. 6 groups. What's going in each group? 30 put into 6 groups would be 5, and that's what's left over. Look at that. Look at that. Plus 12 x's put into 6 groups, there'd be 2x per group, 2 x's per group. And there it is. Let's do that little double check one more time, or again. 6 times 5 is 30. 6 times 2x is 12x. That checks out. And again, you got the plus sign here. Make sure you got that plus sign. All right, here we go. 8x plus 8. Oh, another good one. This is a classic. We'll be talking about this one for years. 8x and 8. Might look very simple. However, there's something in here that, again, you got to be careful about. One thing is we got to make sure to circle that x. You can't break the x down. We don't know what it is. 8 would be 4 times 2. Circle the 2. 4, you break that down into maybe 2 times 2. Circle the 2, circle the 2. This 8, break that down the same. I'm just going to do the same exact thing. It's the same exact number. Now, key thing is, what do they have in common? Well, they have a 2. And a 2. And a 2. It's like 2 to the third power, 2 cubed. 2 times 2 times 2 is 8. Whoa. So the GCF, the number of groups we can make, would be 8. Look at that. Now, what do they have left over? This is important. Notice, there's not really anything left over here except for the x, and there's nothing left over here. We've crossed off all the circled numbers, so you got to be really careful. If we have 8 x's, and we're going to put those 8 x's into 8 groups, how many per group? Just 1x or just an x. You could put 1x if you want. Some people might like to write that, but 1x is just x. There's 1x per group. Plus, and remember, it might seem like it's 0, but there's 8 things, 8 ones being put in 8 groups. There'd be 1 per group. That's what it would look like, 8 groups of x plus 1. Let's just check that one more time. 8 times x is 8x. 8 times 1 is 8, which is, we got the original 1 back by checking it in that way. It's a good check. All right, so that one's tough because of what goes inside the parentheses. They had all the numbers the same. The variable was different, and then when there's nothing left, it'd be 1 in each group. Okay, again, if you want to try this one in your own, go for it. 77x plus 21. Okay. 77x, make sure you put the x, 21. All right, we'll break down that 77 first. 77 is going to be, 7 times 11. Can't break those down. Of course, you got to circle the x. Can't break down the 7. Can't break down the 11. Now, 21 we can break down into 7 times 3. Circle the 7, circle the 3. All right. What do they have in common? Well, they have a 7. And I believe that is all. 7 is the GCF, and that's it. So, the lights just went off, but I'm going to keep going. I'm going to persist. We're going to make 7 groups. We'll see what goes in each group. Well, 77x divided by 7 groups would be 11x in each group. Plus, 21 put into 7 groups, there'd be 3 in each group. 7 groups of 11x plus 3. All right, so that was a really good practice today with factoring. It's going to help us quite a bit, not only the remainder of this year, but that's going to help you quite a bit in 7th, and 8th grade as well when you get into more complex expressions and equations. So factoring, a great skill, a fun skill, and one that we're a little bit better at now. All right, have a great day. If you have any questions, let me know, and I'll see you soon. Bye-bye.